Morning students. Yesterday we saw about the circle, we saw equation of circle and all the applications. Today we will start the next exercise and topic regarding that I will write first parabola. Now yesterday I taught you and told you and shown you that how we can find the section on the double cone. And parabola I taught you when a particular double cone is cuts in the slant position. In the slant position we get parabola. So let me explain something. Today we will see with the picture, but let me introduce to you with some some words regarding that and how it forms. So one of the important thing yesterday I told the locus. Circle we made. It was just a locus of the point. It followed some condition like the point P, moves such that its distance from a fixed point C is always same. Then the locus of the point forms a circle. So today we will look for parabola, and I will again go with the locus. Suppose it is a point P. It is a moving point. It is a variable point. Suppose this is a fixed point. We say it is focus. Try to understand. So P is a moving point, variable point. S is a fixed point. We say it is a focus. And this is the line. This is the line, and we say this line is fixed line called a directrix. It is called a directrix. So remember three words. This is my directrix, this is the focus, and this is the moving point P. Now let me explain that how the parabola creates. So I just tell you the ratio distances of point P, which is moving point, distance of P to S, the ratio of distance of point PS to P and directrix. The ratio of distance of point P to S and to P to directrix is always equal to E, and E equal to 1. Now don't get confused. Let me explain something. I just tell you the locus of point P, meaning we are finding the moment of P, such that a distance to P from P to S to P to directrix, P to S to P to directrix, PS and PM, that ratio is called E. E is actually called eccentricity. And let me explain that in this regard, in case of parabola, E is always 1. Meaning that the ratio of PS and PM are 1, or PS equal to PM, in the sense that when PS equal to PM in all the cases, in all the moment of P, the obtained figure will be parabola. When we will trace the path of the point P, we will get the parabolic figure. I again explain. Don't worry about the hard language. Initial language is only PS upon PM is always E. E is called eccentricity. In the case of parabola, this eccentricity is 1, meaning PS upon PM is 1, meaning PS equal to PM. It means that, while it's a rough figure, that's why both looks different. This is shorter one, this is a longer one. It seems, but it is not. The reality is that these two are equal actually. And now we will find the path of the P where it follows PS equal to PM. Like if P is coming here, So this time PS will be equal to PM. If P is coming here, as PS equal to PM, when P is coming here, PS equal to PM, and P is coming here, PS equal to PM, as P is coming here, you can understand that in all the way, when we see the path of the P, we will know that, we will have that these two distances are always equal, these two, you know, these all distances are equal. And when you will find trace the path, so this is P, this is P, this is P, and P. When I will join all the points, I would have very important figure. It is a parabolic figure. So you must know that parabolic figure only can be obtained when P follow PS equal to PM or PS upon PM equal to 1. And remember that PS upon PM is always a centricity. Centricity is 1 in the case of parabola. So this is initial definition, student. You must know. Now let me tell you that how we can get the equation of parabola. So remember PS equal to PM. This is only the definition which we will use for finding the equation of parabola. Okay, let me rub this out now. And I again rub all the figure and then I'll go on. The particular, this is axis now. And let me tell you one thing, that we are gonna looking for certain type of parabolas. Certain type of parabolas. Like what? First thing, I am making the parabola where this kind of parabola we'll look for. This is along the x-axis, right side of the particular y-axis. This, the point where it actually turns, this is called the vertex. This is called the vertex of the parabola where it moves or turns itself. So this is a parabola, it turns from origin, meaning that origin is its vertex. So we are looking for certain parabolas whose vertex is origin point. You can understand that this is a first parabola, which is actually right side with the O is the vertex point. Now I will make a second one, this kind of parabola where again vertex is so origin is a vertex. Third we will look for this kind of parabola, and last one is this kind of parabola. In these 4 certain parabolas we will have origin is vertex, right side, left side, upward, downward. So okay, we will one by one look the equations of these parabolas. So first of all, first certain parabola I have taken here. This is the parabola whose vertex is the origin point, and you should know that inside the parabola we have one S always called focus. So remember that this time it is on the x-axis, so y coordinate will be 0. And initially that particular the value of x coordinate of s is taken a. This is a certain symbol, certain distance. Remember it only that in the case of the parabola, when it is right side of the y-axis with the origins of vertex, this focus is always having a coordinate a comma 0. And it means that this distance is A. This distance is A. And let me tell you one important thing. When I was telling you the path of the point P, what I taught you, that was P, that was Directrix, that was S. So this distance are equal. When this distance are equal, when P will come here, this distance are equal. What you felt that this is a Directrix. P point, the distance of point P to S and distance from point P to the directrix are always equal. So this is my point P, and let me explain one thing, that when we talk about P is coming here, suppose this distance and this distance are always same, meaning I have to make the directrix such a way that these two distance must equal. Then look at P is coming, suppose here, so these two distance must equal. Suppose P is coming here, these two distance must equal, suppose it is Z. So remember it that about the directrix I want to tell you one fact, that from the vertex, the distance of the vertex to the focus, distance of the vertex to the directrix should equal. These two distance should equal. If it is A, this is also A. If it is A, it is a minus A0 because it is a left side of the origin point. So remember this particular fact, students. Now let me explain something, that this is my point P, which is always taken XY. And what is the fact? You know that PS and PM are always equal. This is by definition of the parabola. We know PS equal to PM. We know PS equal to PM. This is not, should not be surprised. Recently we had seen the definition of parabola, that PS upon PM is E is always 1, so PS equal to PM. So PS equal to PM is the definition of a parabola, and now I will put the values. Look at first of all PS. So PS, we know that PS meaning distance from P to S. By distance formula we can obtain. But what is PM? So PM is actually distance from P to the directrix. So very important thing, that directrix is a line. Directrix is what? Line. So I will find first the equation of that directrix. This is a directrix. And I will find the equation. And I know that you can tell. This is a directrix which is itself a line which is parallel to the y-axis, and any line parallel to the y-axis is equal to what? X equal to constant. X equal to by which it is passing. It is passing from minus A. So x equal to minus A. So x plus A is equal to 0. It is none else, but it is an equation of directrix again. Now, what do you think about PM? PS is very simple. One should know that PS is none else, but it is a distance of P to S, and distance formula you can use. X2 minus x1 square. Y2 minus y1 square. Y minus 0 square is y square. But this is important, PM. So PM meaning distance of P to M. So P is a point, and directrix is this is a PM, this is a line, and line's equation is x plus A. And this is a line, this is a point. So how we could find the perpendicular distance of the line from the point? I think I taught you. Can you see here again? X1 y1 is a point. Ax plus by plus c is, this is a point, this is a line. How we can find the perpendicular distance? Remember, mod A, instead of x we write x1, B, instead of y we write y1, C upon coefficient of x square, coefficient of y square, A square plus B square. This was the way. So same I will use here. The way, PM meaning, now this is my point and this is the line whose equation is x plus A. Now what is the answer? What would be the answer? This x will come at the place of x, same will be there. Y will come at the place of y is not here, leave it. A will be there. Coefficient of x square, it's a 1 square. Coefficient of y square, y is not here, so 0 square. Lastly, I will speak one thing, that x minus a square plus y square equal to x plus a only in mod. One should know that this is no meaning. I square both sides, square both sides. After squaring, x minus a square plus y square there, this will remove, and one should know that mod is also removed because on doing the square, mod always gone from there. Meaning when I remove the mod, it will be plus minus, but after doing the square, it will definitely remove from there. So only this will be obtained. Now open it by all the way to a minus the whole square is a square, b square 2ab plus y square equal to a square plus b square plus 2ab. Now what will cancel? These two cancel and these two cancel. I think we have reach the answer y square 2ax, 2x will be 4ax. What you have obtained, this is phenomenal formula ever you will see for parabola y square equal to 4ax. This is the formula for parabola formed right side of the origin with vertex origin. Focus is always a0 for that, and directrix is always situated as equal distance of the vertex, vertex to the directrix and vertex to the focus always maintain the same distance. So this is the formula where we talk about you should understand that the point A particular will form S. For particular parabola's equation, you have to remember initial things, that in this case S is a focus, A0 will be there. In this case, the directrix equation is x plus a equals 0. In this case, the vertex is origin point. These certain things you must remember. Okay, now let me rub this out. Please remember this particular formula. Now I will tell you one interesting thing here. Look at. Let me rub again, and I tell you some about. Again, I will make the parabola, same parabola. This is my SA0, and this is the directrix as usual. Directrix. Now I will tell you something. Try to understand. Can you focus? This was my P. I am not taking P now. This is the line which is perpendicular to the x-axis passing from S. First I tell you that I didn't make a P here. I am taking one line which is actually perpendicular to the x-axis passing from focus. It is called lattice rectum. Now try to understand and read the language. Lattice rectum. Lattice rectum we will study that this is the line passes from focus and perpendicular to the axis. Now let me tell you some about lattice rectum. Suppose it is L and it is L dash. L dash. So first of all I tell you the equation of the parabola you know now. What is the equation of parabola? You know y square equal to 4ax. Second thing, what is the equation of lattice rectum? Lattice rectum is itself a line. And its equation you can find easily because this line is none else but parallel to the y-axis. And when it is parallel to y-axis, your answer is x equal to constant by which it is passing. So it is passing from a0, so x equal to a will be there. So x minus a is equal to 0 is the equation of lattice rectum. Now, equation of lattice rectum, we have got x minus a is equal to 0, or you can say x equal to a. Now, why I have written these things? Actually, I want to find the distance of the lattice rectum. Can you see? This portion is the distance of the length of the lattice rectum. Length of the lattice rectum, L to L dash. How we can find out that? So, I will find the coordinate of L and L dash. Now, my question is, what is L? So L is intersection point of parabola and the lattice rectum. Parabola and the lattice rectum. Parabola and the lattice rectum. And we can find the intersection point by solving them. Remember in class 12 it will be helpful to you guys that whenever you need to find the intersection point of any two line or any two curve or line and curve, we only merge them. And find the values of variable. Like what? It is x equal to a. So we already got the value of x now. So x equal to a put here and get your value y. By equation y square equal to 4ax, put x equal to a here. Like that. So 4a square like y equal to plus minus 2a. It means that plus minus 2a, don't get confused. So L will be, L have a x coordinate a and y coordinate 2a, and L dash is none else but x coordinate is a and y coordinate is a minus 2a. Try to understand. X coordinate is a and y coordinate is a minus 2a because we are having y twice value of y, plus and minus. So plus for that and minus for that. And we got an L dash. Now if I say length of lattice rectum length of lattice rectum, meaning distance from L to L dash, and you know the distance formula in class 10 you read that L to L dash distance is A minus A square minus 2A minus 2A square. So lastly it gonna be 0, it gonna be minus 4A square, meaning 16A square, meaning 4A. This is the length of the lattice rectum you have got. So this is very important things I'm telling you. Now I'm again rubbing this section and I will tell you the conclusion. What abstract we have found till now. The abstract we have found till now 5 things for equation. This is the equation of parabola. This is the equation of parabola and what we have obtained first. In this regard, what is a vertex? What is a vertex? So vertex is origin point. You understand it is origin point. It is a vertex. Now second, what is a focus? So focus we have seen. We need not write that. Focus we have seen A0. We have seen it. Third thing. What is the equation of directrix? What is the equation of directrix? You know that this is passing from minus A0. I taught you that parallel to y-axis it is x equal to minus a. So answer is x plus a is equal to 0. Fourth is lattice rectum, length of lattice rectum, shortly LR, length of lattice rectum we recently have seen it's a 4a. And last is equation of axis. It's very important. You will feel that we have 2 axes. So why it is asking for that? Actually, equation of axis about the parabola is formed. So this parabola is formed about the x-axis. So definitely equation of axis meaning the axis, the equation of axis about along which it forms. Now this parabola is forming along the x-axis. So we have to write the equation of x-axis here, and which is y equal to 0. So these 5 things are certain things you guys have to remember particular for this particular parabola. Suppose I ask you, I put example, find all these 5 things for y square equal to 5x. This is my question. This is my question. So how you will do? You don't worry. First you compare equation by y square equal to 4x because it looks like same. Y square equal to positive 5x, y square equal to positive 4x. You compare. So when you compare guys, the coefficient of x is 4a. So coefficient of x is 5. So a will be 5 by 4. A will be 5 by 4. Okay, now you got it. Now first answer, vertex. So vertex is as usual same. Second, focus. Focus will be A0. So what is A? 5 by 4 and 0. Third, what is equation of directrix? What is equation of directrix? Know it. It is x plus a equal to 0. X plus 5 by 4 equal to 0. 4x plus 5 is equal to 0. This is answer equation of directrix. The fourth is lattice rectum. It's a 4a. 4a 5 by 4 and this cancel 5. And last, equation of axis. So its answer is x equal to y equal to 0. So these are all the answer we can easily find from first parabola which looks like y square equal to 4ax. So hope student you getting it. Very interesting it is. It's very interesting it is. So let me rub this out. Now I just tell you the few other parabolas which I will directly tell you because the one I have explained very well. Each and everything I explained deeply. Now I will tell you the rest parabolas second. Now look at the equation. Y square equal to minus 4x. This time I have written the equation directly because now I'm not telling you the derivation by which I got it. Actually, the same thing will be obtained. PS equal to PM is initial definition of the parabola. We will follow and get answer. So let me make the picture here. This is x dash, y dash. This is parabola. and this is the Directrix. Now quickly I tell you, this is my focus. This is my focus. This time focus is actually left side of the origin. It's gonna be minus. So this is gonna be Z now, and it is a positive. So what is the equation of Directrix? Parallel to the y-axis. Parallel to the y-axis is always x equal to constant by which it is passing. So x minus a is equal to 0. It is the equation of Directrix. Now everything is again certain. This time it is a P, and P is equal to always Pm. That is the definition. So by using the definition you will get the same answer. Now I am not telling you again and again to make a figure in the mind that whenever it is y square equal to negative sign, you have to form the parabola like that. In this regard I tell you 5 things. First, you know vertex. Vertex is as-usual double zero. Second, focus. Can you see the focus here? Focus is a minus a0. Third thing is the equation of Directrix. Equation of Directrix is I wrote here x minus a equal to 0. Fourth is the lattice vector. Length of lattice vector I didn't form, but it is always 4a. And fifth is equation of axis. And equation of axis again, this is the parabola is again along the x-axis. So equation of axis is y equal to 0. So this is the 5 things we have obtained for this particular parabola. Now the next is the third one. X is equal to 4ay. Look at easy. It is again x dash, y and y dash. So we have a parabola upward. Remember, again its vertex is origin point. This time focus will lie here and Directrix will lie here. This time focus will 0a. Why? Because it is on the y-axis. And this is going to be 0 and minus. So what is equation of Directrix? You can understand. Same as the Directrix is parallel to x-axis. So answer will be y is equal to constant by which it is passing from minus. So y plus a is equal to 0. That is answer. So what 5 things will obtain? First, vertex as usual double zero. Second, focus. Can you see focus? 0 and a. Third is equation of Directrix. We already have found here y plus a is equal to 0. Fourth is lattice vector. The length of lattice vector is always 4a for any kind of parabola. And fifth is equation of axis. Equation of axis. Can you see that the parabola is lying along the y-axis? So what is the equation of y-axis? X equal to 0. So I will write here same. And last but not least, guys, that fourth one it is x squared equal to minus 4ay. This is like that. This is a way of making it. This is the Directrix, and this is focus 0 and minus a, and this is 0 and a. So what is the Directrix equation? It's parallel to x-axis, y equal to passing from a, so y minus a equal to 0. It is equation of Directrix. And 5 things again, right? And what is vertex? Double zero. Second, what is a focus? See here, focus is 0 minus a. Third, equation of Directrix we already have found there, which is y minus a is equal to 0. Fourth is a lattice vector, always 4a. And fifth is equation of axis by which it is formed. It is formed along the y-axis, whose equation is x equal to 0. So now hope you got each and everything. First you would have given the parabola's equation and you will be told to find these 5 things. So you first identify that your parabola looks like this or this or this, the first one, and then according to that you don't need to make a picture, but first find by comparing A. So A is very important. After finding A you can go with the formulas and get your answers. So hope you have got. Now in next lecture I will tell you the exercise. Thank you.